Okay, boys and girls, here we are with our next section, Chapter 10, Section 1, Make Predictions. Now, what I'd like you to do is go ahead and write down these vocabulary words and their definitions, and then press play once you have them all down, and I'll go ahead and talk to you about them. Okay, the first word we have, statistics. Statistics has to deal with collecting, organizing, and interpreting data. That means making sense of the numbers. Now, a survey. A survey is how we collect the data. Now, a survey can be anything from asking somebody a question, or maybe watching things to see what happens, smelling things, tasting things, feeling things, and so forth. It doesn't have to be about people, it can be about anything. I can watch animals cross the road to see how many do it. I can, watch the clouds go by. I can analyze soil samples, all kinds of things. The population. The population is what is actually being studied. It's what you want to know about. Now, usually, you don't have the time or resources to study the population, so instead, you'll study a sample, a part of the group. So, for example, if I wanted to know about the rocks in my state, I wouldn't necessarily have time to look at every single rock in the entire state. Instead, I would look at a sample of the rocks from all over the state, and I would use that information to make a prediction about all the rocks in the state. Another great example of this is if you ever look in a newspaper or you watch the news and they make a prediction, blah, blah, blah amount of people like this or hate that. Well, chances are they didn't ask every single person in that area how they felt about something. Instead, they asked a sample of the population how they felt about something, and then they made a prediction. For example, if 90% of the people in their sample liked pepperoni pizza, they would assume 90% of the people in that area like pepperoni pizza. Now, sometimes the predictions are off. Sometimes they're way off. They're not always accurate, and you have to know that. But we'll talk more about samples, what makes a good sample or a bad sample, what makes a good prediction or a bad prediction later on in another section. Let's take a look at an example of how to use the numbers from a sample to make a prediction about a population, what we're doing in this section. Okay, so suppose I asked students in one of my classes to bring in a picture that represented what they did on spring break. And the results that I got were 6 students brought in pictures from the beach, because they went to the beach all spring break, 4 pictures from camping, 7 students just watched Netflix all spring break, and 11 went to a park. And I wanted to know what's the probability that a picture would be from the park, since I have results. This is experimental probability. And I wanted to know, out of 560 students, how many would have a picture from a park. So, take a minute to copy this down, press play when you have it all ready, and we'll go through the explanation. Okay, so for the first one, pictures from the park. Well, there were 11 pictures from the park, and it was 11 out of how many? Well, if you add 6, 4, 7, and 11, that's a total of 28 pictures. So, 11 over 28. In future questions, we'll ask you to turn this into a decimal and a percent. For number 2, out of 560 students, how many would have a picture from the park? Well, what we're going to do is we're going to pretend this is our sample for this population. We're going to use this information to make a prediction of this population. So, if 11 out of the 28 students in my sample had a picture from the park, I want to know how many of the 560 students in the population would likely have a picture from the park. I solved this with cross products. 11 times 560 equals 28 times x. 11 times 560 is 6,160. And to eliminate this coefficient, I divide by it on both sides. That cancels, leaving x. And 6,160 divided by 28 is 220. Now, does that mean that in a group of 560 students, exactly 220 will have a picture of a park guaranteed? No. But that's our prediction based on the results from our sample. Okay, let's take a look at another example. Okay, so let's say a survey found that 6 out of 10 students tweet on Twitter. So I want to know, 1, what's the probability that somebody tweets? This time, not only do I want a fraction, I also want a decimal and a percent. And 2, if there are 250 students in a group, I want you to make a prediction using this sample information. Make a prediction to figure out how many of those 250 probably use Twitter. Go ahead and try and solve this problem, and then press play when you're ready. I'm going to give you the solution, and I'm also going to give you an alternate way to solve number 2. Okay. So for the first one, it says right here that 6 out of 10 students use Twitter. So we have 6 out of 10 for our fraction. Now we can reduce that. Don't forget to reduce if you can. That reduces to 3/5. As a decimal, remember, top divided by bottom, we would get 0.6. And to turn this into a percent, multiply by 100. So that would be 60%. These are our answers for number 1. Don't forget to reduce. For number 2, we're going to use this information to make a prediction to see how many out of 250 we think would use Twitter. Well, we end up with 6 out of 10 equaling how many out of 250? Sample result equals population result. Now, if you used 3/5 here, you would still get the same answer. 6 times 250 is going to equal 10 times x. 6 times 250 is 1,500. Divide both sides by 10 to get rid of that coefficient. And we end up with 150 equals x. Now I told you there was another way to solve this. The alternative way is to use percent of a number. We learned this many, many chapters ago. Percent of a number would be this. Since we found out 6 out of 10 students in our sample was 60%, well, 60% of the students in our sample use Twitter. We would assume that 60% of our population would use Twitter. So, 60% of 250 is what we're trying to figure out. Well, 60% as a decimal is 0.6 or 0.60. You multiply that by the population, 250, and when you do that in your calculator, you end up with 150. So either way, we get the answer. If you like this method better, that's fine. Go ahead and use this method. If you like this method better because you're used to it, that's fine as well. What I really recommend is use both methods. That way you can check your answer. If you do it this way, try this to check your answer, see if you're right. You should get the same answer both ways. Okay, let's take a look at another example. Okay, so suppose we have the results right here from a survey. 54% of the students liked pepperoni pizza, 46% liked cheese pizza. Well, if we have a group of 1,725 students, predict how many would like cheese pizza. Go ahead and try and do this problem. You will get a decimal, and I will tell you what to do with it. Press play when you're ready. Let's see how you do. Okay, so there's two ways to attack this problem. One way is with cross products. Let's take a look at that. So we know that 46% of the students like cheese pizza. Percent means over 100, so this is 46 out of 100. And that's going to equal how many out of our population of 1,725. Well, we do the cross products here. So we have 46 times 1,725 equals 100x. 46 times 1,725, that's going to equal 79,350. Now to get rid of this coefficient, we're going to divide both sides by 100. And when we do that, we end up with 793.5. Now, here's the thing. When you're doing these problems, if you come up with a decimal, if it's something that can be split up easily, naturally, for example, pounds of sugar or ounces of water, you can have 3.5 pounds of sugar. You can have 793.5 ounces of water. That's fine. But if it's something that can't be split up easily or naturally, like people, for example, then you need to round. So here, remember, 5 or more goes up, 4 or less, get rid of it. So we would say this is about 794 people. Things like people, glasses, staplers, cars, things that you can't easily split up without breaking them, damaging them, or killing them, that's when we use rounding. Now, if you decided to use the other method because you thought it was a little quicker, it would look like this. 46% is 0.46. We multiply this by the population, 1,725, and again, we get the same number, 793.5. And again, we have to round that, since it's people, to 794. And boys and girls, if you understand all that, you should be pretty set for this section. See you in class.